Harsh, is your internet connection is okay?
Sir, my internet connection is weak, sir.
Okay, fine, no problem. Are you getting these things now?
Yes, sir. Yes.
Actually, these are some just the basic definitions. You have to just remember what is conductivity and all that. Conductivity, conductance, mobility, current density. So in case of current density is a vector quantity. Current density is a vector. You can say current density is a vector brother of current. Current is a scalar, but current density is a vector brother of current. If current density J is current density is non-uniform, current density non-uniform means current is changing with respect to area. At different area, the current is different. Suppose if you want to find the current at this area, then the current will be same. Current will I. Here also the current is I. Non-uniform. Then you will use this. If you want to find the current, then you will use the integration J dot dA, and current density is a vector quantity. But current is not a vector quantity, and direction of current density is same as that of current. Same as that of current. And SI unit, if you will talk about the SI unit, then the SI unit of current density is ampere per meter square. You can calculate the unit of current density from here. J is equal to I divided by area. Unit of current is ampere. Unit of area is meter square. But usually in NCERT of 12th class, you will get uniform J, uniform current density. This is non-uniform, but in NCERT, usually you will get, in 95% cases, you will get uniform current density. There is one more thing I want to write. Microscopic form of Ohm's law. Microscopic form of Ohm's law. So microscopic form of Ohm's law is given as J current density is equal to sigma into electric field. Either you can write in this way, or you can write J is equal to sigma is 1 upon resistivity into electric field. Okay, Harsh?
Yes, sir.
Have we solved the question on the resistance? Okay, we have not solved. We have not solved the question on the resistance. So, okay, so now you can note it down, and after that we will solve some numericals. Have we solved the numericals on the resistance and resistivity?
No, sir.
Not solved. That student is someone else. You can write from here. These are some just the basic things, basic terms.
Sir, the sign for conductivity is new, right? Sorry, rho.
The sign of conductivity is sigma.
Sigma. And
Sigma
then
is
resistivity is rho.
resistivity is rho. Sigma we have seen somewhere else also. Sigma.
Yes, sir.
Remember? Do you remember? Sigma
Sir,
surface charge density.
surface area density.
Yeah, surface charge
Electrostatics,
density
sir.
in
Yes, sir.
electrostatics. Yeah. In
Yes.
capacitor. And I have given one question also in the test. Find the ratio of surface charge density.
Yes, sir.
Hmm.
Sir,
Hmm.
what is that symbol for current density? Is that Joule?
Symbol for the
Current density.
I J, that is in ABCD we have I, capital J, and I write J like this. You can write J like this.
Okay, it's J.
J.
Done, sir.
Okay, done.
Oh, okay.
I am writing here also. This J factor is the current density. Sigma is the conductivity. I am writing all meaning of all these symbols. E is, you know already, electric field. Rho is the resistivity.
Done, sir.
Okay. Now we will solve the numerical on the resistance and resistivity. We will solve. Now see. Before that, I am just give, uh, giving you the introduction of the formulas. Means not the introduction, means just revising. The formula of resistance is the potential difference divided by current. This is the formula of resistance.
Yes,
And
sir.
resistance can also be write as ml divided by a n e square tau. And resistance can also be write rho L divided by A. So we have the formulas of resistance. These are the formulas. And rho is m upon n e square tau. We have the formulas of resistance. So now I am having a question. This is a conductor, suppose cylindrical conductor. This is the cylindrical conductor having the area of cross section as A and L, capital L, as the length of the conductor. A is the area of cross section and rho is the resistivity of this conductor. Rho is the resistivity of this conductor and this is the area of cross section here. And when you will see this area of cross section, the area of cross section will look like the circular. This have a circular area of cross section. Circular cross section you have. So the radius of this circular cross section is given as R. Getting?
Yes, sir.
So we have to find the resistance of this conductor. We have to find the resistance between, suppose here is a point 1 and here is a point 2 and this is connected with some battery and we have to find resistance between point 1 and 2. Find resistance between point 1 and 2. So see here what I am going to do. We have the formulas of resistance like this: potential difference divided by current. See, no current and no potential difference is given here.
Yes, sir.
See, no mass or and mass and this is not given, so I will not use this formula also.
Sir, I just had a question.
We will use this formula.
Sir,
Yeah.
in the second formula of resistivity,
Resistance.
Yeah, so resistance. A is the area, right?
A is the area of cross section.
Okay.
A is I have written already these all the things.
Yes, sir.
So here also A is the area of cross section.
Yes, sir.
Area of cross section. Cross section. Area of cross section here is this area. This area is circular. Cylindrical area. Have you seen the cylinder? No? So the
Yes,
cylinder
sir.
has the circular cross section area. See here. This have a cylinder. So this is circle. So you have take the
Yes.
area of this circle. So you will use the formula of resistance R is equal to resistivity into length divided by area of cross section.
Yes, sir.
So you have R resistance. You want to find the resistance R. You have the value rho. You have length L.
Yes, sir.
And what is the area of cross section of this circle?
A.
Area of circle is pi.
Pi r square.
Very good. Pi r square. So you will write here pi r square. So this is your answer. Now we will solve one more question.
So can you scroll up?
Oh, okay. I will give you the time for
Okay,
noting.
okay.
Okay. Just see here if there is a cuboid given like this. What? Okay, now it's fine. This is a cuboid given and length of this cuboid is L, height of this cuboid is H, and width of this cuboid is small v. This is given to us, and
Yes, sir.
on this face 0.1 is given, and on this face 0.2 is given. On this face 0.3 is given. On this face 0.4 is given. We have to find the resistance between 0.1 and 2, and also resistivity of this material is given. Rho is the resistivity of the material of this cuboid. This is cuboid. Find resistance between 0.1 and 2 and 0.2 and 3 and 4. Now we will use the formula R is equal to rho L by A. This is the first question. This is the second question. So for first question, if you want to find the resistance between 1 and 2, so you have this cross section area. See here. We know this is length. All the things we know. We know this is height H, width V. I want to find the resistance. See here, between on this is the face of this cuboid. This is one face,
Yes, sir.
and here is another face. This is another face of this. Between these two faces, we have to find the resistance, and we have the formula of resistance R is equal to rho and length divided by area of cross section. So area of cross section, you will take this cross section area. Okay, Harsh? And length you will take this L.
Yes, sir.
So R
Yes,
will
sir.
become, rho is given as, L is given as, what is the value of area of this? This is the area of, this is rectangle. So area of rectangle you will take
Yes.
H into V. So this is your answer. Resistance between 1 and 2. Okay, if you want to find
Yes, sir.
second answer, see here for the second answer, so we know that this is the length and all that. This is the length L. This is cuboid and density rho is given. Now we have find the resistance between point this. So now we will find the resistance between point 3, means this is the face on which the point 3 lies. This is the face on which the point 3 lies. And this is the face on which the point 4 lies. Okay. So now if you have to find the resistance between point 3 and 4. So you will take density, resistivity rho, and what is the length of point between 3 and 4 is H.
H. Sir.
H. And what is the area of cross section this time? This will be the area of cross section, this
Yes, sir.
rectangle.
Yes,
So
sir.
the area of this cross section, if this is length L, so area of this length into breadth, if this is length into breadth is the area of cross section.
Yes, sir.
So L into V. So this is the resistance. Now you can note it down. You have to identify the points where the points are located. Accordingly, you have to put the values in the formula of L and area.
Yes, sir. Done, sir.
Okay. Now note it down. you should know when you will take the length, when you will take the area and length will change accordingly.
Yes, sir.
The area and length will be changed accordingly as the points will change to find the resistance between the points.
Yes, sir.
Yeah.
Second scroll down. Done, sir.
Okay. We will solve one more question. Length of conductor is increased by 10%. Calculate percentage change, or you can say percentage change in resistance and resistivity. Length of a conductor. I am supposing the conductor as the cylindrical conductor, and suppose initially the length of the conductor is L, small l, and A is the area of cross section of this conductor. Now the length is increased of this conductor. Now the length of this conductor is increased. This length is increased by 10%. Length is increased 10% means finally the length will be L plus L into 10 by 100.
10 by.
This is 10% increment.
Increasing the length. Yes,
yeah,
sir.
you are increasing length 10%. 10% is this. So
yes,
final length you will have L plus this will become 0 0 cancel 0.1 L, then you will have final length 1.1 L. This is the final length. So finally the length is 1.1 L you have. But we don't know the area of cross section. I am supposing A final is the area of cross section finally. We know that the volume of the, if this is the pen, I am stretching this pen and length of this pen is increased. Length of this pen is increased, but the volume will remain same.
Yes, sir.
Volume will not change. So on increasing the length, in this question, volume of conductor will remain same. Will remain same. Volume will remain same means I am representing Vi as initial volume of conductor.
Yes, sir.
Initial volume of conductor, and I am supposing Vf as the final volume of conductor. Final volume of conductor. So volume is not changing means V initial is equal to V final. V initial, we know volume is given by area into length. So initially this is area into length. What A final? Finally, area is A final and length is 1.1 into L. So finally area is length and length cancel out. We have A divided by 1.1. This is final area of this conductor after stretching the length 10%. And
Yes, sir.
I am yeah. Do you want to
Nothing,
ask?
nothing, sir.
Okay. And this is the conductor. So I am supposing Ri is the initial resistance of this conductor. As the resistance depends upon the length and area, so resistance will change. So I am supposing R suffix F is the final resistance of this conductor after stretching, final resistance. So if you want, and resistivity is rho, resistivity will remain same.
Yes, sir.
As the material of the conductor is same, the resistivity will remain same. So you
Yes,
can
sir.
say as the material same, rho will same, because rho depends only on the material
Yes, sir.
in this question. Will see. So if I want to write the value of resistance for this, so can I write R initial is equal to rho L divided by A?
Yes, sir.
Okay, I am just writing initial resistance. R initial is equal to rho L divided by A. And what about the final resistance? Rho is same.
Yes.
L is 1.1 L. Area is A divided by 1.1. Area is 1.8 A divided by 1.1. So when you will solve this, you will get rho L by A into 1.1 square. Square of 1.1. This 1.1 will go in the numerator and multiply by 1.1. 1.1 into 1.1 will be 1.1 square. So you have R initial, you have R final. You can now calculate the percentage change in the resistance. Percentage change in resistance is given by, this is known as delta R percent. You can say this is given by percentage change of anything, percentage change of current, percentage change of charge, percentage change of volume, percentage change of area is always final value minus initial value divided by initial value.
Initial
So
value.
means final value, final resistance minus initial resistance divided by initial resistance. So now you can put the value here. What is the value of final resistance? You can do one thing more here. Divide R this with I and this will
by
become,
A.
yeah,
1.1 whole square.
yeah, RF RI minus 1, and you will multiply this with 100. Multiply this thing with
100.
Either you can solve by putting the value here, and I have just divided this RI with this with this. So you can write what is the value of final resistance? Final resistance is rho L by
Rho
A.
L by A 1 into 1.1 whole square.
Divided by initial resistance is rho L by A.
Yes, sir.
This is minus 1 and multiplied by 100. So this rho L by A is gone. So you have now 1.1 square minus 1 into 100. So this will become 1.21. 1.21 minus 1 into 100, and this will become 0.21 into 100, and when you will multiply you will get 21%.
Yes, sir.
Delta R percentage change in resistance will be 21%, but on the same way you can calculate percentage change in resistivity, means resistivity percent you can write. This will be 0 because the material is not changing. This is 0. I am just writing here. There will be no change in resistivity. There will be no change in resistivity rho because the material is not changing. We have the same wire before and earlier. We are not changing the material because the material is same. So percentage change in resistivity equal to 0%. Now you can note it down. Got this question?
Yes, sir. Sir, you can scroll down, sir. I wrote till the last part.
Okay, fine.
Done, sir.
Done. Very good. Here is one more question we will solve. Question is, a current of 1 ampere is flowing through the copper wire flowing through copper wire of length 0.1 meter and area of cross section is given as 10 to the power minus 6 meter square. If the specific resistance and specific resistance is also known as resistivity. Specific resistance, if the specific resistivity of copper wire is 1.7 into 10 to the power minus 8 ohm meter. This is given. First, we have to find potential difference across the ends. Calculate number 1, potential difference across the ends. Potential difference across the ends. Secondly, we have to find the current density. Thirdly, we have to find the if there are one free electron, there is one free electron there is one free electron per atom in a copper, then calculate the drift velocity, given that density of copper, I represent density as this is the density of copper is given as 8.9 into 10 to the power 3 kg divided by meter cube. And atomic weight or molecular weight of copper, that is capital M. You can say this is atomic weight, or you can say molecular weight. Molecular weight is given as 63.5, and total number of atom in copper means, and not the total number of copper. If n is the number of total number of atom, okay, leave this. So we have to find all these terms. Now read the question carefully and find the related terms. This is 10 to minus 6. So see here, I am just solving it.
So just want to read the question.
Okay. Please write the question first and read the writing with reading.
Yes, sir.
Yeah. The last part of this question is quite good. All the things are rest things are very easy. Last part of the question is, I will say, little bit. Okay.
Done, sir.
Done. Okay. Now see here.
So,
This completed now?
yes, sir.
Okay, okay. So we have a copper wire. We have a copper wire. Have you read the question?
Yes, sir. So, just one, can you show the density?
The density is given as 8.9 into 10 to the power 3 kg
Okay.
divided by meter cube. So see here very carefully. The copper wire is given. This is a copper wire I am taking.
Yes, sir.
Always try to make the diagram, and length is given to us 10 to the power minus 6.
Yes, sir.
Not 10 to the power minus 6. Length is not that. Length is given as length is given as 0.1 meter. This length is given. Area of cross section A is given as 10 to the power minus 6 meter square.
Yes, sir.
Okay. And density of this copper, density is given. Density rho is given as 8.9 into 10 to the power 3 kg divided by meter cube. And molecular weight is given. Molecular weight.
Yes, sir.
Molecular weight, or you can say atomic weight. Chemistry. Mole concept. 11th class. Do you have a mole concept in the chemistry? In
Yes,
12th
sir.
class? In 12th class
Yes.
also.
12th, we didn't study in 12th till now, sir.
You have a chapter, pressure ratio type chapter, something. In physical chemistry. Which chapter you have in chemistry, do you know?
Yes, sir.
Do you know the name of the chapter? Any name of the chapter in chemistry?
Yes, sir. I did solutions, haloalkanes,
Solution.
haloarenes.
Okay. In solution, we calculate the number of moles, molecular
Yeah, we
weight.
calculate, but there was no like mole concept given
Yeah.
there. But
Okay, fine. Just I am telling like this. So see here now. First part of the question is they are saying current is flowing, 1 ampere current is flowing
yes, sir.
in this wire. This is a wire and this current is flowing like this. And this current is given as 1 ampere.
Yes, sir.
1 ampere, no? Okay, 1 ampere current is flowing. And resistivity is given rho. What is the value of resistivity? 1.7 into 10 to the power minus 8
Minus 8.
ohm meter. Now we have to calculate the potential difference across the ends. So if the current is flowing, means this is connected with some battery.
Yes, sir.
Obviously this will be connected with otherwise how the current will flow? Current
Yes,
will
sir.
not flow. Battery of some potential difference V. We have to find this V. We have to find this V. So first answer is we have to find the potential difference V, and we have a formula I into R.
V is equal to IR.
We have I, but we do not have R. For R, we will use rho L by
R
A.
is equal to rho L by A.
So V is equal to I into rho L by A. I is 1. Rho is 1.7 into 10 to the power minus 8.
Yes, sir.
Length is given as 0.1 meter and area is given as 10 to the power minus 6. When you will calculate this, you will get the answer 1.7 As simply you can say this is 10 to the minus 6. When you will go up, this will 10 to the minus 2 and
minus 2.
this will 10 to the minus 3. So this will
Yes, sir.
become 10 to the power minus 3 volts. So potential difference is this.
Yes, sir.
Second part, we have to calculate the current density.
J.
Yeah, very good. Current density, that is J, and J is equal to current divided by area of cross
Area.
section.
Yes, sir.
Current is given as 1 ampere and area of cross section is 10 to the power minus 6. So the value will become 10 to the power 6 ampere per meter square. Ampere, unit of current is ampere. We have this answer of current density. We have this answer of now the good question. This is a good question. We have to find the drift velocity. We have
Yes,
to
sir.
find the drift velocity. So see how I will calculate the drift velocity. We have many formulas.
Yes, sir.
You have the formula of drift velocity like this. I is equal to E
E
tau divided by M.
by M.
But we have this.
Yes,
We know
sir.
the charge on electron. We know the mass of electron. But
Mass.
we do not
We
have
don't know the
relaxation time.
relaxation
So
time.
we will not use this formula.
Yes, sir.
But we have one relation between the current and the drift velocity. I is equal to area, number density of electron, ANE, and drift velocity. So
Yes,
from
sir.
here we can calculate the drift velocity I divided by ANE.
ANE.
ANE. And now this time we have I,
Yes, sir.
1 ampere. We have area of cross section 10 to the power
Yeah,
minus
10 to
6.
the minus 6.
We have E as 1.6 into 10 to the power minus 19.
Yes,
But
sir.
we do not have N.
Number
We do
of
not have N is the number of electrons or
yes,
number
sir.
of electrons per unit volume. Per unit volume means
Volume.
in 1 meter cube the number of electrons per unit
Yes, sir.
volume.
Yes, sir.
So we have to calculate this thing. We have to calculate. If we have calculated this, then we can calculate the drift velocity easily. So
Yes, sir.
number of electron per unit volume. So what you will do, take volume 1 meter cube, volume 1 meter cube of the conductor, and density is given. Density.
Yes, sir.
Density is given as 8.9,
8.9 10 raised to minus 10 raised to 3.
10 to the power 3. Density is given. And we know that mass is equal to mass, MAAS mass. Mass of the copper. I am just calculating the mass of copper wire 1 meter cube for 1 meter cube.
Yes, sir.
Are you getting my point? I am calculating
Mass
the
for 1 meter cube of copper wire.
mass of 1 meter cube volume of copper.
Copper.
So mass is
Yes.
equal to volume into density of copper.
Density. Yes, sir.
I am representing mass of copper with M. Volume is given as 1 and density is given as 8.9.
8.9 10 raised to 3.
10 to the power 3.
So it is
Why?
same, sir. 8.10.
Why I have taken volume 1 meter cube? Because we have to find
Number of
free
electrons
electron
per unit volume.
in 1 meter cube we have to find. That is why I have taken volume 1
Yes,
meter
sir.
cube. So the mass will become
8.9 into 10 raised to minus 3. 10 raised to 3. 3
kg.
Yes, sir.
We have this mass in kg.
Yes, sir.
Now what should we do? There is a problem. This is the mass of the copper.
Yes.
Now there is one thing, very interesting thing. Number of moles. That is why I was asking the chemistry, do you know? Number of moles of copper in 1 meter cube is equal to mass in gram. You will take mass in gram. Arey, you have formula of mole. Number of moles is mass in gram divided by molecular mass.
Molecular weight, yes, sir.
Yeah, molecular weight or molecular mass. So mass in gram, you will take, convert this into the gram. 8.9 into 10 to the power 3. This is in kg, and 1 kg is equal to 10 to the
1000 gram.
power 1000 grams. So you will multiply here with -3.
-3.
And molecular weight is given as
63.5.
63.3. When you will calculate this, you will get number of moles in 1 meter cube of copper will
Yes,
be coming out to be. Okay, we have this number of moles in 1 meter cube. We have this number of moles in 1 meter cube. Number of moles in 1 meter cube.
Yes, sir.
Now we have this number of moles. We have, I am representing number of moles with, okay, no. Actually, we have one more small n. So number of moles we have this value means 8.9
into 10 raised to 3 into 10 raised to
this
minus
is cancel out. This is cancel
yes,
out.
sir. Yeah, of course.
This will become 63.3.
63.3.
We have number of moles, and we know that in what, if we have 1 mole, then number of atom in 1 mole.
Yes, sir.
Number of atoms of copper in 1 mole is equal to 6.023 Avogadro number.
Yes, sir. 6.023 10 raised to 23.
Very good. 10. And this is Avogadro number is represented by n.
Yes, sir.
Now you have this. If you want to calculate total number of atom of copper, total number of
We multiplied with
atom,
Avogadro.
copper. In 1 meter cube, then you will multiply this with this.
Yes, sir.
Why we are multiplying? Because in 1 meter cube, in 1 mole we have this much of electron. In this much of mole we will multiply this 6.023 into 10 to the power 23. So we will have total number of copper atom is it come out to be 9 into 10 to the power 28. You will find the answer.
Yes,
9
sir.
into 10 to the power 9 into 10 to the power 28.
28.
10 to the power 28 atoms.
Yes, sir.
Total number of atoms.
Yes, sir.
In 1 meter cube, we have 9 into 10 to the power 28 copper atoms.
Yes,
so
sir.
In 1 meter cube, 9 into 10 to the power 28 copper atoms are there. And they are saying in one atom there is only one free electron.
Yes, sir.
See here, they are saying each and every statement of the question is important. They are saying one free electron per atom in copper.
Yes, sir.
So number of free electron in 1 meter cube, we have this number of atoms.
28 copper.
So total number of free electron in 1 meter cube, total number of free electron per meter cube, that is small n, will be 9 into 10 to the power 28, because number of copper atoms equal to number of free electrons, because
yes,
there is only one free electron in one copper atom. So you
yes,
have
sir.
the value of Now we have calculated the value of small n. Now we can calculate the drift velocity.
Yes, sir.
Drift velocity is
I. Okay. I by ANE.
Okay. So I is given as 1, area is given as 10 to the power minus 6, and now we have n.
Yes, sir.
So all the
9
hard
into
work,
10 raised to
we have done is to calculate this.
n.
Charge on electron is 1.6 into 10 to the power minus 19.
Yes, sir.
I am just talking about the magnitude, so I am not taking the charge of electron as negative. When you will calculate this, you will get the answer. Drift velocity 6.94 into 10 to the power minus 5 meter per second. So this is the final answer. So now you can note it down.
Yes, sir.
The last part of the question is quite good.
Yes, sir. Sir, can you just show the third part, sir? I've done first and second.
The third part. This cross meaning, we will not use this formula. Actually, I am just removing this. I don't want any confusion. I want to tell you why I have not used that formula, because we do not have the value of relaxation time. That is why I have used this relation. And what is the value of A here? A is the area of cross section, N is the number of free electrons in 1 meter cube. You should remember the meaning of all the terms here.
Yes, sir.
I'm just writing here now. So A is the area of cross section. Area of cross section. N is the number of electrons, number of free electrons per unit volume. E is the charge on electron.
Yes, sir.
V suffix D is the drift speed, or you can say drift velocity without.
So guys, hold on.
Yeah.
Sir, a little bit up, sir.
Yeah. And M is the molecular weight here. This M is the molecular, or you can say
So guys, hold on.